Today we're going to go over sine waves and sinusoidal functions. Okay? The first thing we're going to do is kind of try to define what a sinusoidal function is. And we talked about this the other day about periodic functions. So a periodic function is something that has a repeating pattern, right? So let's say we talk about climbing up and down something over time. This pattern repeats. This is considered periodic. Okay? A sinusoidal function is periodic, but it has an actual look to it. It has a wave look. Okay? So this is considered sinusoidal. And it usually refers to, not always, but it usually refers to kind of traveling in a circular motion over time. So let's say we have our Ferris wheel, or it could be a teacup maybe, and you're traveling around and around something. Okay? Thinking of, let's say we start here on our Ferris wheel, then we go up, then we come back down to the same point, then we're at our lowest point, and we come back up again. Time, because it's always moving forward, we would not represent this as a circle on a graph. Okay? Because over time, if we were to go around this 2, 3, 4 times, maybe 4 periods, if you guys remember when we were talking about periods, over time it would have this type of effect, just going up and down continuously, forever. Okay? And this shape is what causes a sinusoidal function. Now, one of the functions that we're going to learn about, which you need to know for your assignment, is a sine wave. Okay? This is a sinusoidal function. So what we're going to do is we're going to actually try to graph this sine wave. What we're going to do is I'm going to put in some negative values for x. So, for instance, a negative value for x, negative 90, negative 180, negative 270, negative 360, and then we're going to continue that pattern. Okay? So let's continue this pattern here. We'll start with 360 negative. So when x is 360, we put negative 360 sine, we get 0. So our y-coordinate is 0. Sorry, give me a second. So like we said, negative 360 gives us a y value of 0. So this is a coordinate. One of our coordinates is negative 360 and 0. Now, I've chosen very big numbers here. I should address this. We're used to working with our trig because remember we use sine in trig in degrees. So think of these like they're being marked in degrees. So negative 360 degrees gives us a y value of 0. Let's go to our next value we have on the chart, specifically negative 270. 270, when x is negative 2, oops, wrong button. When x is negative 270, our y value is 1. Okay. Okay, so I've gotten a 1 here. Let's go to the next one, negative 180. Oops. 180, when it's negative, put in the sign, we get 0 again. Pattern's coming down. Let's try negative 90. When 90 is negative, we get negative 1. Okay? And then 0, so sine 0 is 0. Okay, so this part's tough. I could have something that looks like this, straight lines. And remember, straight lines wouldn't give us our sinusoidal look. So I'm just going to test something else here. I'm going to test in between. Anyone know what would be directly in between 360 and 270? Okay, it'll be negative 315. Okay? Negative 315. So we're going to put that value in. If it's going to make a straight line, it'll probably be at 0.5, correct? So let's put in 315. When it's negative, we get 0.7. That gives us a number that means that we're going to get a value that's probably closer to here. Okay? And technically, to make the wave, I need to get all of the values. I'll try the next one in between these two. In between 270 and 180 is going to be negative 225. Okay? So 225, when it's negative, our sine value is, again, negative, or sorry, 0.7 again. And if we continue this pattern, we're going to find out that these two values fall around our highest point. So what's actually happening, if we were to put them all in, we're actually creating a wave type of function here. Okay, so this is the relationship we're getting with our sine wave. So now these coordinates starting at 0 and 0 are very important, and I want you to remember them. where do you guys think 90 would be? What would the y value be? 1. So we continue that pattern, we get 1. What about 180? 270? Negative 1. 360? Okay. These 5 points are very important, and I would like you guys to memorize them so that it becomes much easier to graph this type of function. 80, 0, 270, negative 1, and 360 and 0. Where do we think 450 is going to be? It's going to be back up to 1, and negative 450? Negative 1. Okay? So these functions continue on forever. This is a sine wave function. Now there's many parts of this function that are very important. Let's talk about the highest points and the lowest point. So, what's the y value of our highest point here? 1. This is known as a peak, or maybe also known as a maximum. What's the lowest value? Negative 1, right? And this is known as a trough or a minimum value, okay? Now let's say we want to talk about the range of this function. So how high and how low does it go? We need to take, for range, our formula is our max minus our minimum. Okay? So our max is 1, and we subtract our minimum, which is negative 1. What do we get? 2. So the range of this function, it goes from negative 1 to 1. That's a value of 2. That's important for what we're doing here. Okay? So we know what a peak is, a trough, and a max and a min, which are the same. We know what the range is of this function. Okay? There's a line that travels through the middle of this function. Okay? And we'll color it red. It's known as the equation of the axis. Okay? So it's pretty obvious to see the equation of the axis is going to be when y is 0 here. But we need to calculate this. So our equation of the axis, scroll down a little. We're going to call it EOA, which stands for equation of the axis. Our EOA is we're going to take those two values and add them together and divide by 2. So we're going to take the max plus the minimum and divide it by 2. So what was our max value? 1. What was our minimum value? 1. Okay. Divide that by 2. What is 1 plus negative 1?
0.
0. What is 0 divided by 2?
0.
0. So our equation of the axis is at 0 when y is 0. So we have a horizontal line going through 0 on the y-axis. Okay. So we have our equation of the axis, EOA. And think of it, say we were to relate that to this Ferris wheel we drew. Our equation of the axis would be a line kind of going through this middle here. Okay. Our peak would be the highest point, or our max, and our minimum would be the lowest, or the trough. Okay. Another thing we need to talk about is something called amplitude. Okay. An amplitude is how far from the equation of the axis it is to go to the top or to the bottom. It should be the same distance if we have the right equation of the axis. So amplitude, it's another formula. This time it's max minus the minimum divided by 2. Okay? So we take our max value, which is 1 again, and we subtract the minimum, which is negative 1. What is 1 minus negative 1? Divided by 2? Our amplitude is 1. In other words, the distance from the equation of the axis to the highest point is 1. And the distance from the equation of the axis to the lowest point is also 1. That's right. That would be our amplitude. Okay? How far that distance is. So just like PJ just said, amplitude is range divided by 2. And think of that if we're talking about a circle, our amplitude would be the radius. Right? How far it is from the middle to the outside of the circle. That's what our amplitude would be. And finally, now we've talked about this before, a period. We need to figure out what the period of this function is. Now, a period is how long it takes for the function to start repeating its pattern. Okay? So, I'm going to actually cut this one in a different spot so that we can figure out how to calculate it. I'm going to go from this highest point to this highest point. we know that the pattern is starting to repeat again at that point. So from this top, we go down, we come up, and then it starts to repeat. Okay? So in order to calculate the period, we have to take those x values and subtract them. Okay? So let's take our x values here. We take one of them and subtract the other. So for our period, one of the x values we had was 270, and the other one was 90. Okay? So let's take the larger one and subtract the smaller one. In this case, that would be 90, subtract negative 270. Okay? There really isn't a specific formula because these values always change. You have to choose what x values you're going to subtract. So think of it as x1 and x2. We subtract the two for the period. When we subtract these, what do we get? The period, which happens to be 360. So it takes 360 degrees for this pattern to start to repeat itself, which makes sense. It takes 360 degrees to get around a circle because we're showing a circle in this case. Okay? So that's how those things will relate to each other. Sorry, there's one other thing I do want to talk about because it's very important for your assignment. The domain and range. Let's talk about domain first. The domain of this function. What would the domain of this function be if it goes on forever? XCR. X is the element of all real numbers. Okay? So that's very simple. The domain of this is our x is the element of all real numbers, especially because it's continuous. The range is also continuous. So we're going to start our range with YER. But there's a restriction. So we put our line in here such that, what is the restriction in this case? Is it just one? So y is greater? What is it? Okay, so we have our max and our min. Those are going to help us find our range. So we're going to have y is greater than and equal to, because it touches, -1, and less than and equal to +1. Okay, and I'll make them distinctive ones. So it's a little different from that such.